Hi everyone, in this chapter we're going to be learning some geometry. These two sections are about angle measurement and quadrilaterals. When we're labeling angles, we need to understand how to do that. If you look at this part, this is called the vertex, and of course these are the sides of the angle on each side there. We can name an angle with the letter in the middle, right, like this. So that would say angle ABC. We can also name it with just this letter, angle D. Now, if we had other letters over here, we'd probably have to list, like we did here, the ABC. Or we can use an E or a letter that's inside the angle, and we would call that angle E. Basically, you just want to be sure that when you're naming the angle, it specifically shows that angle. Here are some different types of angles and how we classify them. On the first one, we have some angles that are called acute angles, and they have an angle measure that is less than 90 degrees. Obtuse angles are greater than 90 but less than 180. And you can see that those are usually, of course, wider because they're going to be greater than 90 degrees. And right angles have a 90 degree angle, right? Exactly 90 degrees. And the two sides of the angles form perpendicular lines. Straight angles are equal to 180 degrees, and we will use that information sometimes to figure out some angle measures. If we have more than one angle on this, like we had something like this, we could actually use the 180 to help us figure those out. Lines are not very straight. A circle, a full circle, has 360 degrees. A quarter circle is 90, half circle is 180, and so on. Vertical angles. Vertical angles can be identified by the fact that they are kind of across from each other, like this. Those angles are called vertical angles. This rule says when two lines intersect, the vertical angles are always equal. In this drawing, angle P is equal to angle R, and angle Q is equal to angle S. And that's because they are vertical, and it would make sense, right? The angles, the two lines are going to make the same angles on either side of that, or either, the ones that share the vertex there right in the middle. And I think it makes sense when you just look at them and think about it. On the number one, it says find the measure of angles A, B, and C. So angle A is vertical to the 40-degree angle. So we're going to say 40 degrees for A. B and C are vertical, but also we have a straight angle here, right there. So that means that B plus 40 is 180. We just take 180 and subtract the 40. So B would be 140 degrees. And since, I'm going to write this in a little bit better, 140, that means that C is also 140 degrees. Now we're going to talk about some triangles. The interior angles of a triangle always add up to 180 degrees. They're showing this triangles and the three angles, and when we put them together, we get 180 degrees. So it's kind of showing kind of like a proof that when we have the three angles, they equal 180 degrees, or the sum of them would equal 180 degrees. So if you have two of the angles, like here we have angle Z is 33 degrees, angle Y is 122 degrees, and we're looking for angle X. So what is angle X? We can find that by subtracting from 180, or we can combine these first and then subtract from 180. So we take 180 minus 33 plus 122. That's 180 minus 155. And then that tells me that angle X is 25 degrees. So anytime you have a missing angle, it's easy to find if it's in a triangle. Angles form from parallel lines. When the lines are parallel, and it's going to tell us that they are when we're trying to do this, we have something also called the transversal. So you can see where that is, right? The line that's going through these parallel lines. When that happens, we have certain relationships between the angles. If you took a geometry class before, you would have heard of some different ones where we talk about these and they have certain names, but we don't really go into that depth of this, just an understanding of that this transversal goes through these in the same way. So the angles formed are going to be equal depending on where they're located. In this case, we're showing 70 degrees here. And that means that we have several angles in this drawing that are going to be 70 degrees. We have the vertical one, R, that's 70. And then we also know that S will be 70 because it's located on the other parallel line in the same position. And then, of course, W is vertical to S. We can use straight angles to find angle P. Angle P then is going to be 180 minus 70, so angle P would be 110 degrees. Q is vertical from P, and then T is in the same position as the P is on the first parallel line. On the second line, that's the second line parallel to that one, it would be the same. And then, of course, we have vertical angles. And so we have 110 or 70 for all of our angles. And usually just labeling in the drawing is fine and an easy way to do that. But just to reinforce that, that's the measure of all our angles. So these are a few practice problems we will work on here using what we've learned so far. So let's just go through each one. On the angles formed in part A, we have 125, and so B is vertical to that. It would also be 125. If we subtract 125 from 180, we get 55. And then angle A and angle C are both 55 degrees because they're vertical to each other. On part B, we have this angle that is 16 degrees, so E would be 16 degrees also, since they are vertical. If I take 180 minus 16, then I would get 164. Yeah, I might want to do that. All right, so angle D is 164 degrees. Angle F is vertical to angle D, so 164 degrees there. On C, right, that's a straight angle. We actually had this relationship on the previous problem of 70 and 110 because we simply take 70 and take 180 and subtract 70 to get that angle measure. Now this next one might be a little more difficult. We have parallel lines. You can mark parallel lines like this if that is helpful. And that means that we have this relationship with the T to the 75 degrees. Together, those are going to make 180 degrees. So that means that our T would be 180 minus 75. That's not going to fit there very well. Let me just do 180 minus 75. So angle T is 105 degrees, right? 105. And then we can look at some of these other ones. So this would be like a transversal through my parallel lines right here. So that means that 65 plus K would have to equal 180. So angle K would be 180 minus 65, which is 115 degrees. And then our last one, this X, would be related to the T, so the difference between those two would also be 75. right? 180 minus 105 is 75 because they have to add up to the 180 since we have our transversal going through the parallel lines on this side. On E, we have vertical angles, so the S would be 60. T would be 180 minus 60, so T is going to be 120. All right, let's look at the last one. So on this last one, we could look at the fact that we have this straight angle right here. So that means that Q would be 30, right? 180 minus 150 would make that 30 degrees. That means P would also be 30 degrees because of vertical angles. And then we can figure out W because we have 30 and 60. So 180, if we look at the other straight angle, let me show you that one here. 180 minus 30, whoops, I'm going to change that, minus 30 minus 60. And so this angle is 90 degrees. It kind of looks like it's 90 degrees, but we had to actually do the math there to make sure that it really is. You can't just go by the fact that it looks like it. Maybe it was 91 or maybe it was 89, you know. If it's real close, it would be hard to look at it and just know that. Okay, so number 5, board 1 must be joined to board 2 at a right angle. If angle X is 42, what must angle Y be? Well, they're going to add up to 90 degrees. So all we have to do there is subtract to find angle Y. We would take 90 degrees minus 42, and we end up with 48 degrees. On number 6, in the pipe flange shown, the 8 bolt holes are equally spaced. What is the spacing of the holes in degrees? Well, this is a circle, so it has 360 degrees. We would simply take 360 divided by 8, and that's how we would calculate the distance between those, which would make that the holes would be spaced at 45 degrees apart. All right, so I'm going to stop here because we're going to start talking about quadrilaterals on the next slide, and that would be a good start to the second video.